In this lesson, we will learn about the bottom-up assembly modeling using SolidWork. It is hoped that by the end of this lesson, you will be able to create a new assembly, insert component into an assembly using all available technique, utilize the assembly-specific aspect of a feature manager design tree to manipulate and manage the assembly, insert sub-assemblies, and use part configuration in an assembly. This lesson will examine assembly modeling through the construction of a universal joint. The joint consists of several components and one sub-assembly. The bottom-up assembly is created by adding and orienting existing part in an assembly. Parts added to the assembly appear as a component part, and the component parts are oriented and positioned in the assembly using what we call as mate. Mate relate faces and edges of component part to planes and other faces and edges. So in this lesson, we will make an assembly using already existing component. The assembly is a universal joint and is made up of a number of individual parts and one sub-assembly as shown here. So we have a crank sub, we have a yoke mail, we have a bracket, and we have two copies of a short pin and one long pin. Then we have a spider and we have a yoke female. So this lesson will examine the assembly modeling through the construction of a universal joint. The joint consists of several components and one sub-assembly. So what is a bottom-up assembly? Bottom-up assemblies are created by when we add and orienting existing parts in an assembly. Parts added to the assembly appear as component parts, and the component parts are oriented and positioned in the assembly using mates. Mates relate the faces and edges of component parts to a plane and other faces or edges. So this is the assembly that we will construct in this lesson. We will make an assembly using the existing components. The assembly is a universal joint, like what I have mentioned earlier, and is made up of a number of individual parts and one sub-assembly as shown here. So this assembly consists of a crank sub. This is the crank sub, and yoke mail, bracket, and we have a short pin and a long pin, and we also have a spider. We have a spider in the middle here, and we have a yoke female. And we can actually rotate the crank sub here so to see the assembly move. So the first step in creating this assembly, what we have to do is we want to open an existing part. So we open the part bracket, and this part will be the base component of the new assembly. And the first component added to an assembly should be a part that will not move. And by fixing the first component, others can be mated to it without any danger of it moving. So how do we create a new assembly? New assemblies can be created directly or be made from an open part or assembly. And the new assembly contains an origin, the three standard planes, and a mates folder. So to create a new assembly, you go here to new, and we make assembly from a part, and you just left click. And then you just select bracket and you click OK. Here we place the component at the origin by placing the cursor like what I have shown before at the origin, or by simply clicking OK. And we can save it. We save the assembly under the name universal join, save as universal join. And we can see here that the assembly files have the file extension SLD ASM, and we just save it. So the next step is if we want to add a component, and once the first component has been inserted and fully defined, other parts can be added and mated to it. In this example, the yoke mail part will be inserted here and mated, and this part should be underdefined so that it is free to rotate. So how do we insert the yoke mail? Just go here to insert component. You can find it at the top here on the left top. You can just drop down and we insert component, and you click browse, and we select a yoke mail part. Just click open, and we just position the component on the screen to the left of the bracket and click to place it. And then what we have to do next is we just select the cylindrical faces of the yoke mail here. This is the cylindrical faces that we have to select. We select the cylindrical faces of yoke mail and also the cylindrical faces of our bracket here. So if we want to mate these faces to these faces, we can go here to mate, and at the mate selection, like what I have mentioned before, we select the cylindrical faces of our yoke mail here, and also the cylindrical faces of our bracket here. And we can see here as the second face is selected, the mate is previewed by moving to the position that would result from the mate, and the mate pop-up bar, mate pop-up toolbar is displayed, and we can see here the concentric is selected as the default, and the mate is a preview. And we can see at the mate selection here, the faces listed in the mate selection. We have a phase 1, cylindrical faces of yoke mail, and we have a cylindrical faces of our bracket here. And we just save the concentric mate, and we just click OK. And the next step is we just rotate and view slightly. The view slightly, we just rotate it. Here we can see that the yoke mail is still free to move up and down. So what we have to do next, we just rotate the view slightly and select the underside planar face of the bracket component. Here we select these faces. And then we return to isometric view. Just return to isometric view and select the top face of our yoke mail here. And we can see that we have add a coincident mate to bring the selected faces into contact. So we can see here coincident mates has been automatically chosen. and we just click OK. And we can see here at our design tree here, the mates concentric and coincident remain listed in the mates group box, and we can see concentric one and mates, and we can see a coincident mates here. And the yoke male component is listed under constraint. Means that it is still be able to move by rotating around the cylindrical. Means that the yoke male here is still able to move by rotating around the axis of its cylindrical surface. And you can taste the behavior of a yoke male here by dragging it using your mouse. And here, if you click on the face of our yoke male here, you can see the breadcrumb. This is what we call as a breadcrumb for that selection that appear in the upper left portion of the graphics area. And when you right click on any of the icon, allows you to edit that feature, and clicking the A will deselect the face. So another way to add component to the assembly is through Windows or my computer. The part of assembly file can be dragged and dropped into the active assembly. So you just open the file that containing the part or component that we want to add to our assembly, and you just drag and drop into the active assembly. And what we want to do next is we want to add a concentric mate between the two cylindrical faces of the spider. This part is what we call as a spider, and we want to mate the cylindrical faces of the spider to the yoke male component. So to do that, you just left click on mate above here, and we select the cylindrical faces of spider here and the yoke male component, and we can see that the concentric mate will be automatically added between spider and yoke male component, and you just click OK. And what we want to do next is we want to make sure that our spider here is located between the two faces of our yoke male component here. And to do that, we will we'll be using advanced mate tapes. Just click insert mate, and then click advanced. You select advanced mates here. Just drop down and we select width. Select width here and click centered. We have a few selection here. We have a centered, 3 dimension and percent, but for this by this time we just select a centered. Advanced mates often require additional selection. In this example, the 2 pairs of selection are required. And in width selection, we click the pair of the inner faces of our yoke male here. So we just click this face of a yoke male, and we rotate it a little bit when we select another faces of a yoke male. And in tab selection, we select a pair of outer faces of our spider here. So we select these faces and another one. And here we can see that the mate will keep the spider centered inside the yolk male here with equal gaps on each side. So you just click OK. The next step that we'll be doing is we want to insert and rotate. And to do that, we want to insert yolk female part in our active assembly here. To do that, we just go to insert component. You select insert component, and you select yolk female. Just click open, and when you see the yolk female in our active assembly here, do not click anything yet. And we can see below here we have a X rotate component about X, we have a rotate component about Y, and we have a rotate component about Z. And we click rotate the component about Z twice, 1 and 2, and we just left click to place the component. So I just left click here. I just left click on the mouse and place the yolk female part here. And next, what we want to do is we want to add a concentric mate between the cylindrical faces. This is the cylindrical faces of yolk female. We want to add a concentric mate between these cylindrical faces of yolk female and spider here. So we just go to insert mate, and we select these cylindrical faces and also this face of spider. And we can see that concentric mate is automatically added between the two faces. And we just click OK. And now I want to introduce you to the component preview window. A component preview window is a handy tool that we can use to make a mate selection easier. When a component is selected for use, a separate viewport is created for the assembly and for the component, and each viewport can be manipulated by zooming, scrolling, and rotating. So to use the component preview window, you just click at the spider here, just right click, and we select a component preview window here. And now we can see that the window splits to include both the assembly and the spider component. So it will be more easier for us to add a mate between a yolk female and spider here. And next, we just click insert mate. So here what we are trying to do here is we want to ensure that our spider here is located in between the two faces of yolk female here. So to do that, we will go to advanced mate, and we select a width. And in a width selection, we just we select the two faces of a yolk female here. And in our tab selection, we just select a two. And in tab selection, we just select this face. And we select another one. And now we can see that the spider here is centered on the yolk female component. And we just click OK. We click once again, and we can now exit the preview window by clicking in the exit preview here. Because of the clearance between the yoke of female and the bracket, a coincident mate is unsolvable, so it is not possible, and the gap will prevent a coincident. So what we want to do is we want to add a parallel mate. Parallel mate will keep the selected planar faces of planes parallel to each other without forcing a contact with between them. So to do that, you just move, you just drag and move our yoke female here, move it a little bit. And what we want to do is we want to add a parallel mate between this surface and also this surface. So we just go to insert mate, and we click this face and click this face, and we can see that a parallel mate is automatically chosen, and we just click OK one more time. And if we want to see the gap between these two parallel faces, we can press G on our keyboard, and we can use a magnifying glass to see. We can use a magnifying glass to view the gap, and we can see here there is a gap between the parallel faces of yoke female and our bracket. And now we just return to a isometric view of our assembly by hitting a Ctrl 7.